Hey y'all, I wanted to record this review video for you for ChemBasics before we got too far away from it. Um, in this video, we're going to cover how you read the periodic table, how you calculate protons, neutrons, and electrons for a neutral atom and for an ion, how to draw Bohr models of neutral atoms and ions. We're going to talk about ionic versus covalent bonds in compounds. We're going to talk about how do you identify ionic and covalent compounds, how do you write their chemical formulas, and then how do you draw Lewis dot structures showing their bond. Okay, so this is everything that we covered in our first section of Chemistry of Life material, which was called ChemBasics. All right, so with the periodic table, our periodic table, remember, is a table that's organized all of the elements that are either naturally occurring or man-made from the Earth. The periodic table arranges these elements into groups, which are the columns. Sometimes you hear those called families, but groups. And then periods or rows. Okay, and each of these groups is numbered, and each of the periods are numbered. Now, in each box on the periodic table, we have a few things. We have the chemical symbol. The chemical symbol is always first letter capitalized, so it's either one or two letters long. The first letter is always capital, and if it has a second letter, the second letter is lowercase. Inside of this box, we also have the atomic number, the element name, and the atomic mass. Now, the atomic number is going to tell us how many protons an atom of that kind has, and an atomic mass is going to tell us the mass of the nucleus, and then the nucleus is protons plus neutrons. If you remember, protons are positively charged, neutrons are neutral, and electrons are negatively charged. Now, again, we're talking about these as being elements, and remember that elements are pure substances where we have just one kind of atom. So phosphorus is just made of one kind of atom. It's called the phosphorus atom. So we need to be able to use the info on the periodic table to be able to calculate protons, neutrons, and electrons. Briefly, before we get started with that, I want to talk about group numbers and period numbers. So the group number will tell you, the last digit of the group number, I should say, will tell you how many valence electrons an atom has. So for instance, phosphorus is in group 15, which means it has 5 valence electrons. If you remember, valence electrons are the ones on the outermost shell. I'll touch on those again when we start Bohr models. Over here on this side, period numbers tell us something important about the structure of the atom as well. It tells us how many electron orbital shells that atom has. So for instance, hydrogen only has 1 electron orbital shell. Well, it only has 1 electron, so it's only going to need one of those shells to put that one on. Lithium has 2 electron orbital shells. Sodium has 3, and so on and so forth. Okay, let's start calculating protons, neutrons, and electrons given the info on the periodic table. So we're going to do, let's do nitrogen, okay? Nitrogen has an atomic number of 7 and an atomic mass of 14.007. And I want to know protons, neutrons, and electrons for this atom. So on our periodic table, we find the number of protons as the atomic number. The atomic number is always the same for that element. It never changes because it's what defines that element. Nitrogen always has 7 protons. That can never change. If it did, it wouldn't be nitrogen anymore. So once we have protons, we need to do neutrons. Neutrons, we're going to use our atomic mass. This atomic mass is 14.007, which we can round to 14. Then we subtract our number of protons, because remember it's protons and neutrons that are in the nucleus, and we get our number of neutrons. So if this number is P plus N, then we subtract away P, we just get N. Okay? Now this is a neutral atom. I know this because there's not a charge beside this symbol. So because it's neutral, the same number of protons is going to be the same number of electrons, so 7. Now in nitrogen, we happen to have a 7-7-7 situation. That's not always the case. You must calculate it every time because for a lot of atoms on the periodic table, the number of neutrons is not the same as the number of protons and electrons. So you have to calculate it every single time. Once I know this info, now I can go and start drawing a Bohr model of nitrogen. So I'm going to put nitrogen in the middle right there. And Bohr models show us how many electrons that element has and where they're at. And so we draw electron orbital shells around it. The first electron orbital shell can hold 2 electrons. So we know that nitrogen has 7, so I'm going to put the first 2 on this shell. Then I still have 5 more I need to place, so I'm going to draw a second shell and place 5 more there. That is a Bohr model of nitrogen. Now the second shell can hold up to 8 electrons, and so can the third shell. If you have a third shell, it can also hold 8. So that's the maximum amount you can put on each of these shells before you have to bump up to another shell. Okay, now let's talk about ions. Remember that a positive ion is called a cation, and this ion, we're going to go down in our electron count. A negative ion is called an anion, and for this we're going to go up in our electron count. So these guys lose electrons, these guys gain electrons when they become ions. So let's look at what it would be if you were an ion of nitrogen. Well, nitrogen is a nonmetal. It's on this side of the periodic table, which means when it ionizes, it's going to become a negative ion or an anion. The numbers at the top of the periodic table, what are called oxidation numbers, help me know how many electrons this element is going to gain when it becomes an ion. Same thing with this side of the periodic table. This is going to tell me how many electrons this element loses when it becomes an ion. Because remember, metals are going to be cations, nonmetals, for the most part, are going to be anions in our bonding issues with ions. So, nitrogen is going to become an anion. Okay? It's going to lose electrons. So let's recalculate our protons, neutrons, and electrons for it. Well, it still has 7 protons. Remember, that can't change. It's still going to have 7 neutrons. That didn't change when we become ion. The only time that changes is when you become an isotope, and we're not doing isotopes right now. Now, what does happen is my number of electrons change. Well, my oxidation number or my charge number tells me that nitrogen is going to gain 3 electrons when it becomes an ion. So it had 7 before. If I gain 3, then now I'm going to have 10 electrons. Okay? This is an ion of nitrogen. So what does that look like for my Bohr model? Well, if I'm doing a Bohr model of this ion, I have to gain 3 electrons. I'm going to put 3 more electrons on my Bohr model until I have full valence. So valence shell, if you remember, is the outermost shell. And so when I become an ion, I fill that up. Okay. Now, let's talk about what it would look like if we did a cation. So let's do one of the other ones from the other side of the periodic table. Let's do a metal. Let's do sodium. Okay, sodium has an atomic number of 11 and an atomic mass of 22.990. I want to know protons, neutrons, and electrons in the neutral state first. So that's 11 protons, which is 11 electrons as well. Then I round my atomic mass to 23 because it's 22.9, and I subtract out my number of protons, which gives me my number of neutrons. Okay? I can draw a Bohr model of sodium. This is, again, the neutral state sodium. So on the first electron orbital, I can put 2. Sodium has 11, so I've got a lot more to place. I can put 8. On the second orbital shell, and then I've got 1 more to place, so I'm going to put a 3rd shell with a 3rd electron. So that's sodium's Bohr model. If I want to do a cation of sodium, sodium has a +1 oxidation number on the periodic table, so that means when it becomes an ion, it loses 1 electron. And so we're going to subtract out 1 electron there, and we're going to have 10 now instead of 11 right there. Then I'm going to change that to be my ionic form, And since I'm losing an electron and sodium has this one electron on this outermost shell, I just get rid of that, and now I have the ion, or the cation of sodium. Okay, let's move on to ionic and covalent compounds and how we tell the difference between those. So when more than one element comes together, it forms a compound. If that compound has a metal and a nonmetal, it's an ionic compound. If it has two nonmetals together, then it's a covalent compound. Remember, on our periodic table, we have this stair-step line that defines the border between our metals and our nonmetals. So metals, nonmetals. That's how you tell if it's ionic or covalent. So let's do an example, okay? We're going to do aluminum. Remember, I'm always going to give you the name, chloride. Okay, my first step is to decide whether this is ionic or covalent. So my two elements involved here are aluminum and chlorine, okay? Now, here's aluminum, here's chlorine. This is a metal, this is a nonmetal. So this tells me that this is an ionic compound, okay? Now that I know this is an ionic compound, to find the chemical formula of this compound, I use my oxidation numbers. So the oxidation number for aluminum is +3. The oxidation number for chlorine is -1. I'm going to use the crisscross method to determine how many of each atom are in this compound. So again, I'm going to take this one and push it down here. Take this one and push it down here. And now I get the chemical compound AlCl3. That's aluminum chloride. Okay, AlCl3. Now I need to be able to draw a Lewis dot structure showing this type of bond situation with this ionic bond here. So, since there's only one of these aluminums, I'm going to put it in the middle. Okay? And according to the periodic table, aluminum, which is in group 13, has 3 valence electrons. So I'm going to go ahead and place my valence electrons around aluminum. Then I'm going to put in my chlorines. And I'm going to put 1 on 3 sides of aluminum. Okay? Chlorine, according to the periodic table, is in group 17, so it has 7 valence electrons. So I'm going to go ahead and place those around chlorine. In pairs. Remember, there's 4 sides to the symbol. Now I need to show where aluminum is donating these electrons to chlorine. Okay? This is going to give aluminum a +3 charge, and it's going to give each of these chlorines a -1 charge. So that is a Lewis dot structure showing the ionic bond of aluminum chloride. All right, let's do a covalent compound. All right, covalent compound. Let's do carbon dioxide. Okay, so carbon dioxide. We have carbon and oxygen involved in this compound. Now we need to figure out, is it ionic or covalent? Remember, in covalent compounds, we share electrons. All right, so these shared electrons are between two nonmetals, so that tells us that this is a covalent compound. In a covalent compound, to figure out the chemical formula, we look at the name itself. So this is carbon dioxide. That means we have 1 carbon and 2 oxygens in this molecule, or CO2. Now we need to be able to draw the structure of this. Because there's only 1 carbon, I'm going to put it in the center. And according to the periodic table, carbon has 4 valence electrons, so I'm going to put those on either side. I chose to put them on the sides because I know that's where my oxygen is going to go. So then I'm going to place oxygen on either side of that. And oxygen has 6 valence electrons, so I'm going to place those around oxygen. And now we can see that oxygen is sharing 8 total electrons. carbon is sharing 8 total electrons, and this oxygen is sharing 8 total electrons. That obeys the octet rule, which tells us that this is the correct structure for carbon dioxide. Okay, I will see you guys again with the next video on how to balance chemical equations. I hope this video helps you review ChemBasics. Let me know if I can help you with anything.